Hello, hi everyone, welcome back to the channel and to the series we are solving this blind 75 list. So today in this video lecture we're going to be solving this problem, that is missing number. So in this problem we are just given a nums array which contains n distinct numbers in the range from 0 to n. So we have n numbers and all of the numbers are distinct. Return the only number in the range that is missing from the array. Fine. So we can see that we have n numbers. They are all distinct and the range contains n plus 1 numbers because the range starts from 0 and it ends at n. And we have to return the only number in the range that is missing from the array, right? So basically we have n plus 1 total numbers in the range, and out of those n plus 1 numbers we take some n numbers and we put it into the array nums, right? So we are left with exactly one number in the range, and we just want to figure out that remaining number which has been there, which is remaining in the range, right? So let's better understand it using an example. So you can see that, let's say we have this array like the given in the example number 1. The array is 301. So the array is 301. So we have 3, we have 0, we have 1, right? This is the array that we are having. We can see that we have three numbers, or 3 is the size of the array, okay, and that means the range consists of numbers 0, 1, 2 and 3. Fine. So the range contains 4 numbers, right, starting from a 0 till n, and we have picked exactly 3 numbers out of these 4 numbers to put it into this array nums, right? So this is our array nums. Now we want to find exactly one number which is remaining in this array, and that number is this 2. How we can figure out this number? That's the main that's the question, that's the problem statement here that we have. We can see that one of the simple solutions that may come into the mind is to just sort this array. So we sort this array, we get 0, 1 and 3, right? That means, why do we sort the array? Because the consecutive numbers will be adjacent in the array after we sort it. You can see that all of the consecutive numbers will be adjacent to each other. Fine. So what do we mean? At the very first position we must have 0, at the second position we must have 1, at the third position we must have 2, at the fourth position. So this is the general order that we must have after we sort this array. So we can see that we have 0 at the very first place, that's good. We have 1 at the first place, that's good. But we do not have 2 at the third place, rather we have 3 at the third place. That means 2 is the missing number. So the answer for this test case is 2. That is, 2 is the number which is missing from the range, right? So that's how we gonna solve this. That's how we can solve this problem if we sort the array. So the strategy is simple. Just sort the array, keep a variable, let's call it count, let's say c, or let's say COUNT count. Initialize the count with 0, and now start iterating the array from the very first position. Match this count with the first number. It is matching. Move to the second position and increment the count by 1. It becomes 1. Match this count with the second number. It is 1. That's good. Now move to the third number and increment the count again by 1. So it becomes 2. So match this 2 with this 3. It is not matching. That means, what is that? That means this number here at this position we must have 2, but we do not have 2. That means the resultant is 2. We have to return 2 from this test case. Fine. So this is the first strategy to solve this problem. Let's take one more example to understand it better. So you can see that here we have 0, 1. We have an array that is 0, 1. So for an array that is 0, 1, the range that we have, the n is 2 here, and the range is 0, 1, and 2. So we initialize our count variable with 0. We match this count with the value at the first position. It matches. We increment the count. It becomes 1. Now we match this 1 with the number at the second position. It matches with that. And now we increment the count by 1. It becomes 2. And we end this array. We get all the consecutive numbers in the array. That means the missing number is 2. So out of this range, we picked number 0 and 1 and we put it into the nums array, and the remaining number is 2, and that's my answer. This is the first strategy to solve this problem. So let's just jump to the code implementation part. So let's sort this array. We'll use the inbuilt sorting function, that is nums.begin, nums.end. Take a count variable, initialize it with 0, iterate over the variables, iterate over the numbers in the nums array. If let's say there is a position where it does not match with the count, then we're gonna return that count right from there. So if a particular number is not matching with the count, so we are expecting at that position the number to be this count, C and T, but we do not find it, means that number is missing. So basically by sorting the array, we are rearranging the elements to be at their right places. So 0 must be at the first place, 1 must be at the second place, 2 must be at the third place, and so on. If a number is not at its right place, that means that number is missing. So C and T represent that number. If we find all of the numbers at their right places, we're going to return. That means, let's say we have array of size 2, then we have 0, 1 at the first and second position. And at the third position, then the missing number must be the last number of the range, and that is present in this count variable. So that's the very first naive solution to this problem, and it's not that hard to think about it. It's giving me wrong. Okay, so I forgot to increment the count by 1. Okay, so we have to increment the count by 1, so let's run it. So we are incrementing the count by 1, and now let's submit it. It works. So this is one of the solutions, one of the naive solutions to this problem. Let's discuss yet another solution to this problem. So we can see that we already know the numbers that are present in the range. So the numbers for any range, for nums for an array of size n, the numbers are from the range from 0 to n. This is the range of the numbers which are present in that array. So think about, we can think about another solution. If we already know, let's say we have an array which has a size of nums. So let's take an example. Let's take the very first example. Let's take this example which has 3, 0, and 1. The size is 3, so the range is 0, 1, 2, and 3. This is the range of numbers that we have. Now, the difference between these two arrays, or we can say this is the range and this is the array, is just one number. We have 2 here, we do not have 2 here. All of the numbers are present except this 2 in both of these arrays. So this is my nums and this is my range. So just think about it, how we can get this number 2. If I exclude this number 2 from this range, then all of the numbers which are here in this range are also there in the array? Think about it. What we can do is we can just sum up all these numbers. So 0, sum up all the numbers of the range, 0 plus 1 plus 2 plus 3, and that is going to sum all of the numbers of the range. And if we subtract the sum of numbers in the nums array, then what we're going to get is, so we have 3 plus 0 plus 1. So if we subtract this from this, that is going to give me the resultant number, which is 2. So we can see that 1 cancels 1, 3 cancels 3, what we get is 2. So this is yet another solution to the problem. What the solution says is, we have two types of arrays. The first is nums. We have this array nums basically. Then we have the range, in which we contain all of the, in which we know the range of numbers which must be there in the array from 0 to n, where n is the size of the array. So what we can do is, we can sum up all of the numbers of the range, and we can sum up all of the numbers of the array. Then all we have to do is, let's say the sum of the range of these elements is s, and the sum of the array elements is w. Then the answer would be s minus w, because this will simply be the number which is not there in this array, but it is definitely there in the range, because in the range we are including all of the numbers from 0 to n. Fine. So I hope you got it, how we approached, how we got the solution. So let's try to code it. So all we have to do is just find this s, which is n into, we know what is, let's say we have, so how we gonna get the sum of these n numbers? So we have n numbers, we have a range which starts from 0 to n. So how we gonna sum them? One of the ways is to just loop over these numbers starting from 0 to n and just add all of them into a variable. Another way is to just use the formula n into n plus 1 by 2, which represents the sum of first n natural numbers. So n into n plus 1 by 2. So this is going to give me the sum of first n natural numbers. Let's find it. Int s is equals to n. So let's first calculate the size of the array. Int n nums dot size s, which is n into n plus 1 by 2. Now the second step is to calculate that w, which is the sum of array elements. So let's iterate over the nums array and sum up all the elements of this array. So all we have to do is return this s minus w. That is going to give me my missing number. So let's submit it, and so that is another way to solve this problem. But we are not done yet. Since we are discussing about bit manipulation problems, definitely there is a solution which involves bit manipulation, and this is not that solution because we haven't used bit manipulation. So let's see how we can use bit manipulation to solve this problem. Think about it. Think about the problem statement. We have this array, let's say 3 0 1, and the range that we have, from which we have picked these three elements, is 0 1 2 and 3. So the solution is very similar to the recent solution where we use the sum of n natural numbers. So what we can do is think about an operation which we can use to find this missing number. The missing number is 2. We want to find this number. So think about it. Let's say we have x. This contains the final number. How we can use that? So think about the operation. Let's say we have 1. If I perform XOR of 1 with 1, it will give me 0. If I perform XOR of 1 with 0, it is going to give me 0. It is going to give me 1. This is the property of XOR operation. And if I XOR a number, let's say 3, so we have 3 like this, 0, 1, 1. If I XOR 3 with itself, this is going to give me 0. XOR 3 with 3, it will give me 0. It will cancel itself. So if I XOR this 3 with this 3, this will cancel this. If I XOR this 1 with this 1, this is going to cancel it. If I XOR this 0 with 0, it is going to cancel it. But we do not have 2 in this array to cancel this 2 with. That means this will stay as it is. Everything else will vanish. So the world contains only 2, right? Fine. Everything else in this world vanishes. So how this will give me the solution? So all we have to do is to just XOR these two arrays. XOR all of the numbers in this array, XOR all of the numbers in this array. How? 0, XOR 1, XOR 2, XOR 3, XOR 3. So this basically includes the numbers in this range. And now let's take the numbers of this array. XOR 3, XOR 0, XOR 1. This will cancel this. This 1 is going to cancel this. 0 will cancel 0. We are remaining with 2. And that's my answer. So we simply use this property of XOR, where when we have similar bits and we XOR them, we get 0. And that property gives me my solution. So all we have to do is to XOR all of the numbers that are available to me. The numbers in the range and the numbers in the array. That will give me my answer. So let's take this to be x. Let's start a loop. Start from 1 till this n. So first of all, we need to get this n, which is the numbers, the size of the array. So start from 1 and move till n. XOR all of the numbers there. Then iterate over the nums array. XOR all of the numbers in the nums array. Finally, return this x because that is going to contain my missing number. So let's take some meaningful variable names. Let's call it missing, 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 missing. Let's run this and it's missing. Fine, so this will give me the right answer, so let's submit it. Okay, so I hope you got the solution. This is the bit manipulation solution, but we are not done yet. There are also other solutions to this problem, and that I'm going to give you as an exercise, because the video is going to be too long if I start discussing that solution as well. So just think about binary search to solve this problem. Why? How we can use binary search? We have this range 1, 2, 3, 4, 5, not 1, it starts from 0. So for a array of size 5, the range is this. Fine. And let's say one of the numbers is missing, because that's what the problem statement is. One of the numbers is missing. Let's say 2 is missing. The range is something like this. Now, this is the nums array which we are given, and we want to find this missing number. So think about how we can use binary search. The numbers are ever increasing. We can see that in this sorted array. And for that, we have to sort the array as well first. After sorting the array, how binary search can be used to solve this problem. It's pretty much easy. All you have to do is just find the middle element. So here we'll have some middle element. Then for that middle element, let's say m, we got to check whether the adjacent elements are consecutive or not, because for this element to be at ideal position, what we want is the element at this position, which is to the right of it, must be m plus 1, and the element to the right of it must be m minus 1. If it is not the case, then we have a problem. Okay, one of these three numbers is not at the right position. That's the thing, and we have to figure out which one it is. So let's say we end up at 3. We check for the adjacent numbers. We can see that 4 is adjacent to 3, but 1 is not adjacent to 3. The number that must be there to the left of 3 is 2. Since we do not find 2 to the left of 3, that means 2 is the missing number. Let's say we end up at 1, and we are expecting the number to the right of it to be 2, but we do not find 2 here. We find 3 here. That means the missing number is 2, although the number to the left of it is 0, which is good, which is adjacent to 1. So the answer is 2 for this case. So you can use binary search also to solve this problem. The complexity for that solution would be n log n. Why? Because n log n is consumed for the sorting of the given array, then plus log n will be consumed for performing the binary search, where n is the size of the array. Fine. Now, what is the complexity of the solution which used bit manipulation here? The complexity we can see is, here we are using a for loop which runs for n times, and here we are using again a for loop which also runs for n times. So the complexity would be big of n plus big of n, that is big of 2n, which rounds down to big of n. Fine. So this is a linear time complexity, which is better than the complexity which we get if we use binary search, or we use the first solution which we discussed, that is sort and compare. So we discussed 3 solutions basically, 4 solutions. The first one was sort and compare. The complexity for that solution was n log n. The second was the sum of n natural numbers using the formula n into n plus 1 by 2. The complexity for that solution was big of n. And the third solution is this one. That is, the third solution is using bitwise XOR operation that required the time complexity of big of n. And the final solution uses sorting plus binary search that has a complexity of n log n, which is the complexity of the sorting. So that's all. These are the solutions which can be used to solve this problem, and your exercise is to implement this final solution, that is sorting and performing binary search. And that's all for this video. If you like the video, then hit the like button and make sure to subscribe to the channel, and stay tuned with me for more upcoming videos and updates. So I will see you soon in my next video. Till then, take care. Bye bye.